Hello, everyone. We are live again, and we are here for the fourth time. Can you believe it? If you have been here every single time, whether it's live or you just watch the replays of all of the other sessions together, welcome back. I'm excited that you're here. Can't see your face, but I'm excited for our journey together, and I'm looking forward to hearing your stories of how you're doing better, or maybe understanding things a little bit better. And if you're not there yet, it's okay. It's okay. We're going to work together, and hopefully we'll get to where we want to be. We'll meet our goals. And so we have a lot that we want to go over today. And so I'm going to do a little bit different. I'm going to look at my timer, and when I see an hour is going to be passed, I'm going to say, okay, all right, we'll pick it up next week, okay? But today's topics, I think you'll enjoy. It's something you're probably doing right now in your classes, or maybe something you did in the past that you're just like, man, I could not get it. But hopefully you'll get it today. And the good thing is, because this is recorded, you can watch it as many times as you need to so that you can get it. And yeah, so let's see where we are. Here we go. All right, so let me know, welcome, where you're tuning in from. You can tell me your school name. You do not have to give me your whole name. It's okay. You can keep that private, especially because we're on social media. And I'm looking forward to our journey together. My legal disclaimer, this is just so I put it in your ear. I cannot force you to get an A. I say this every time. You can literally go back and replay the same 3 videos over, and I'll say the same thing. I can't force it on you. You're going to have to work for it. These strategies that I give you, the study tips that I offer, these are things that are scientifically proven to work. Students who have been overly successful or consistently successful in their school or in any endeavor, really, they've shared these tips and said, okay, these are some practices, things and habits that you can adopt now that can affect you even in your class and moving forward. So I hope you would take the time to practice them. And I have another tip for you, and we're going to get that at the end of our time together, okay? So where are we going? How is this going to go? So here we go. We have our opening exercise, and we're going to do that in a second. And then after that, we're going to reteach 1 or 2 math concepts that will help to enhance your understanding. Now, there are some students that are here who have never seen this content before. I want you to know that this is BJC and BGCSE prep, or even for SAT, you'll see these things on those exams as well. But the reason I'm saying that is because it's a boot camp. So I'm not teaching you the foundational things necessarily. I'm kind of picking up where your teacher kind of left off or something, or filling in little gaps here or there. So this boot camp doesn't include everything, but as much as I can pour into you, hopefully you'll receive it, okay? And then we have some exam prep tips. That's going to come to the end, and some resources. Now, the resources, like the worksheets that I make for each session, you're going to go to the YouTube page and go into the description box, and you'll be able to see the link for those downloads, okay? So it's downloadable. You can print them out and literally write on the paper your answers as you go, right? So you have that resource for you. Our YouTube page, once again, our handle is at Reteach Learning, all right? So let's go on into it. Okay, so our exercise today, I was like, okay, what are we going to do? We're online, you're at home. What are we going to do? So here is our opening exercise. What I want you to do is take a look at the picture, and I want you to compare the 2 photos, okay? The one at the top and the one at the left-hand side, okay? Now, I want you to just tell me what are the differences. See if you can note what the differences are. I'll give you a few seconds to take a look, and then we're going to look at the answer, I guess, to see if you actually were able to see those differences, all right? Now, you've probably done this exercise before somewhere where you had to compare, okay, what's different from one photo to the other? So let's take a look at the answer, all right? Here we go. All right, so here are the differences. Everything that's circled are differences. So there's a tree, what is it? Not a tree, but it's a set of birds. We have the window that has something different in it. You have a boy versus a girl, and you have a basketball and a soccer ball. So those are just few differences that are in the photos. So why did we do this exercise? Well, we have a tendency in every area of life, especially because of how society is built up, to compare ourselves to everyone else. I want to get an A because I want to be better than her. Or I want to do this better than that person, and this better than that person, because in our minds, that's how we get picked, right? That's how we advance and get seen. But while we're together, I don't want you to think that this is not a competition, all right? I'm not going to judge you for not knowing the answer. or tell you that you're not smart. Like, no, it doesn't work that way. All right, so where are we going with this? I want you to compete against yourself. I want you to do something today that you didn't do yesterday that helps you to be a better version of who you are, right? So for example, in the area of education, you might say, okay, yesterday or last week, I honestly didn't study as much as I wanted to, or my study time was not as effective. I sat there for an hour, but I didn't learn anything. So what are we going to do different today that we didn't do yesterday so that I can be a better version of who I am, right? How can I be a better me today than yesterday? So the only person you're competing with as we're sitting together is yourself. You're the competition, not Sally or Johnny or whoever other random name you can think of. You're your own competitor, okay? You're competing against yourself. So I just want you to know that you're not competing against Miss Nelson or you saying it right or you do it. No, you're not, okay? Now, does that work in every area of life? You be the judge. But here, it does, okay? So what have we accomplished? So far, we've went through a bunch of things about expressions. We've talked about parts of expressions, simplifying expressions, writing expressions from word problems. Now, I will say this. If you're not really good at word problems today, we're going to spend a lot of time dealing with word problems, okay? Specifically, dealing with equations and solving them and converting from words into equations. So if you did not take a look at session number 2 that talks a little bit more in depth about how to translate between words and mathematic symbols, go ahead and take a look at that, okay? I don't want you to be lost, but we're going to practice that today, all right? And then we have equations. We're going to deal with some equations. So, or we already did equations, our last sessions. We did one-step equations, two-step equations, multi-step equations, and we dealt with equations with variables on both sides. And you had some muscle work. You had some muscle work to take care of. So we're going to go ahead and deal with that next. And let's get started. All right, so this is the muscle work I gave you. Some of you don't like the term homework, so I'm going to coin muscle work. But I really just mean I want you to practice, all right? So, and this also helps the students who did not necessarily get a chance to download any of the worksheets from the description box, or maybe you have your own worksheet, and that's fine. You can practice the same steps using your own worksheet and see how it goes. So here we go. Now, the first thing is when we did our equations, and I have the steps on the lower left-hand side of our screen here. When we did our steps, we said, okay, there's 3 steps that we're going to kind of focus on using and use that consistently to solve these equations. All right, so the first question says, can I simplify on either side of the equal sign? So what I do is I treat this equal sign for now as if it's a wall that I cannot cross. All right, just for this first step. So what do I mean? I'm going to simply look on the left-hand side and the right-hand side individually. So let's look at the left-hand side first. On the left-hand side, I asked the question, can I simplify? And when I say, can I simplify, when we did our session on simplifying equations or expressions specifically, we said, okay, there's some ways we can simplify. We can simplify by combining like terms. We can simplify by distributive property. We can simplify using PEMDAS, right, in order. So let's see if any of those things apply. Well, what I notice is, do I have like terms? Well, I see an x here and I see an x here, and I also see a 2, but the issue with the x's is that one is in parentheses and the other one's not. So can I get rid of those parentheses? And if I can, how? Well, the how is by using distributive property. So if you don't remember distributive property, go ahead, take a look at that video session number 2, and it'll help you through that. So let's go ahead and do it. So first of all, I'm going to leave the 4x for a second because I'm not dealing with that right now. I'm specifically paying attention to the 2 multiplied by the x plus 2. And the distributive property tells me that if I have a number outside of my parentheses, and it doesn't have to be a number, it can be a variable as well, or a letter, but whatever I have outside of my parentheses, and if I have like 2 terms inside my parentheses, I can distribute or multiply the item outside by the 2 individual terms on the inside and add their products. Okay, what do I mean? You can replay that if you need to hear it again. But what do I mean? Well, I'm going to take that 2 that's on the outside, so the 2, and I'm going to multiply by the first term, which is x. And I'm going to add that product. So when we multiply 2 things together, the result is called a product. Okay? And then I'm going to add that to multiplying that 2 on the outside again by the second term, which is a positive 2. Okay? All right. Now, let's go ahead and do the math. What is it telling us to do? Well, the 4x stays there, plus, now 2 times x is simply 2x. It's as if I have two groups of x's, right? So in one group I have an x, in another group I have an x. So how many x's do I have in total? Well, I have 2 x's, so 2x. And then plus 2 times 2 is 4, so that's a positive 4, and that's good. All right, perfect. Now, I'm going to stay on the left-hand side for a second. Can I combine like terms? I did distributive property. I got rid of the parentheses. Can I combine like terms now? Are there like terms? Well, yeah. The like terms, the way you can identify like terms, you can start by looking at the variable first. Now, in this case, we don't have to worry about exponents, but start by looking at the variables. So we have 4x and 2x. Now, x's, when I use the same variable, I'm considering it as if it's like 4 hats or 4 pants, right? So if I have 4 pants and I'm adding 2 more pants, now the x's are like pants. So if I'm adding 2 more pants, and I have 6 pants, all right? So I have 6x and plus 4 just stays there, all right? I didn't touch it. Now that's the left-hand side. I simplified the left-hand side. Now let's take a look at the right-hand side. I have 5, and then it's multiplied by x minus 1. Now in this case, I still have the same distributive property I need to apply, all right? Because I have something on the outside of parentheses. I'm going to go ahead and just put my wall back because it's a little lopsided. All right, so put my wall back right here. Now, let's do the distributive property. It simply says I'm going to distribute the 5 on the outside to every term on the inside of the parentheses, and between each distribution, I'm going to add the product. So what does that mean again? That means I'm going to do 5, let's use a different color, 5 times the first term, which is x. I'm going to add that to 5 times the second term, which is negative 1. Now, one thing we said before is that signs always matter in math. You can't just ignore the sign. It's there, okay? So take a look at the signs. Whenever you go from one step to the next, just double check to make sure that you took care of the signs as well, okay? You didn't just plug the answer in. All right, let's keep going. So 5 times x, similarly as before, is the same as if I have 5 groups of x's. So how many x's do I have in total? Well, I have 5x, so 5x. And now 5 times negative 1, so we have a positive 5, multiplied by negative 1, that's going to give us a negative 5, okay? Now, that wall, these are all equal signs, okay? That's just where the equal sign is. So at this point, I want you to keep in mind that everything is in line. So this is the first row, this is the second row, that's here, and now I'm on the third row. So I'm just going to bring the 5x minus 5 down, okay? So what do we have in front of us? Now that we're here, I'm going to write the last line all together so we're not confused with everything that's going on the top. So I have 6x plus 4, and that's equal to 5x minus 5. All right. Now that we're here, you can take it further, but we have variables on both sides, and the goal is just to get the x by itself. So we did the simplifying, which is our first step. That was a long first step, but we got it done, right? So good job. Now, identify the goal. Our goal is to always get the x by itself, right? We want the x on one side of our equal sign and everything else to go on the opposite side. And one of the things that I told you in the last session, or the session where we talked about equations, is that whenever you get stuck, you're going to ask yourself 3 questions, all right? Now, this is after we did do all of the simplifying and so forth, the first step. But if you're at this point, you get stuck, 3 questions. What's my goal? My goal is to get all of the x's on one side, okay? So how do I do that? What do I see? Well, let's take a look. Let's focus on the x's for a second. So I have a 5x and I have a 6x. Notice at this step, I have no parentheses, so I don't have to worry about that. I already took care of that in step number 1. So I have the 5x and the 6x. So let's say I decide I want to take the 5x over to the left-hand side, or I want to move it from the right-hand side, right? Well, I have a positive 5x. So I'm going to subtract it. That's the way I get rid of a 5x. That's a positive, right? Now, what I also mentioned in our session before is that if I have a number in the front, or a term in the front. This is the same as saying 0, and if the number is positive or the term is positive, it's the same as saying 0 plus 5x minus 5. Okay, the 0 is not there because it doesn't really matter, but I'm putting it there for a visual so you can see that the sign in front of 5x is a plus. So it's as if I'm adding 5x, but it's just a 0 in the front and we don't put the zeros. So if I'm trying to undo an addition of 5x, I'm going to subtract 5x. So minus 5x. All right. Now, in our last session, we mentioned that whatever we do on one side of our equal sign, we need to do it on the other side too. It's an equation. Equations tell us that both sides have to be equal. So whatever I do on one side, I have to do to the other. An example that we use is if your arch enemy was given $20, well, I want $20 too, ma'am. Okay, so you want to go ahead and give both sides $20. And what that also means is if I take $25 from you, you're going to look over there like, are you taking $5 from him too, right? You're going to want it to happen to both of you because that's what's equal. So same thing here. So I'm going to subtract 5x on the other side as well. So let's go ahead and do that. So minus 5x. Now the question is this, why did I put the minus 5x under the 6x? The reason I did that was because they are like terms. They both have the same variable, right? I can't subtract 5x from 4 because they don't have the same variable. Now, if you're confused about that, it's because you didn't go to our last session. So I'm going to keep going, and you can go ahead and catch up after we're done here, all right? So 6x minus 5x is simply x. The plus 4 is going to come down, and that is equal to, now 5x minus 5x is going to be 0. And then I'm going to bring down the negative 5, all right? So the minus didn't just disappear. It's attached to the 5 because I didn't do anything with it. Last and final step, we still want to get the x by itself. What's in the way? What's the problem? Well, the plus 4 is the problem. So I need to do the opposite operation, which in this case will be to subtract 4. So minus 4, and whatever I do on one side, I have to do on the other side. So minus 4. All right, so my answer, I bring down the x. 4 minus 4 is 0. And that is equal to negative 5 minus 4, which is negative 9. Now, some of us have an issue when it comes to adding and subtracting negative numbers. Go ahead and look at my video on number lines, or just practice the number line, right? Just write it out, count it one by one, and you'll be good, all right? So this session is not actually about this. This was just the muscle work we gave last time. So let's get into exactly what we want to talk about today. We have a lot, okay? So we built on the last few sessions we've built on we built some blocks, okay? Some foundational concepts, because when it comes to word problems, most people, if you don't know how to do an equation, you don't know how to solve an equation, if you don't know how to create an equation from a word problem, which is what we talked about before, and if you don't know how to combine like terms and do distributive property and all those nice fancy things, then you're going to get a little bit confused, okay? So in this session, we're going to delve deeper into equations, but specifically in the area of consumer math. Now, some of you are students who don't have a clue what is consumer math, and that's okay. But what it just means is the math we encounter every single day in life. So for example, when you go to the store, at this point, when I was growing up, we didn't have taxes in the Bahamas. At least if we did, I didn't pay them. But yeah, but later on, they added VAT. And so when you go to the store and you buy something, they have one price on the label, but then when you go to the cashier, well, they ask for a little bit more money. It's because there's a tax being added, right? So that's what we talk about when we talk about consumer math. Another area is wages. How much am I being paid for this job? And is it worth it? Am I making more at this job or more at the other job? How do you decide which job you're going to take if income is a factor, right? So that's what we mean by consumer math. Another area is when we're talking about hire purchase. So for example, this is very common, purchasing a house, purchasing a car, purchasing those iPhones that are $1,200 that we can't afford, but we buy them anyway. So all these things have to do with consumer math, okay? And equations are going to help us to make wise decisions when it comes to going to the cash register or taking a job or buying that car or not, okay? So let's get into it. The first area we're going to tackle is percentages. And we kind of already, now the reason I need to talk about percentages is because a lot of these areas that I talked about when it comes to buying cars and houses and commission, which is based on your salary, your wages or whatever, percentage comes up, all right? So some of us don't like percentages, and one of the reasons is because we really don't understand it. But if you understand something really well, then you're a little bit more confident. You're a little bit more confident, and it might not be so daunting, okay? So percentages, we know the uses. We see them in discounts, interest, wages, mortgage. When we say mortgage, it pretty much just means you owe somebody for the house you live in. That's it. Earnings from an investment. Some of you like to go in and out of the stock market or just invest in the stock market. Percentages, that's a big thing. How much percent am I getting back? When you put your money in a savings account in the bank, most people would encounter this every day, but they don't ask the question, what's the percent return on me keeping my money here? Is it better to bank at Bank of America or Bank of Bahamas or Scotia, right? How do I know? Well, this is how you know whether you're going to go at one or the other. So here we go. A percent. What is a percent? First of all, a percent is simply a fraction. All right. Now, some of you, when I said the word fraction, you ran away. Like, no, I don't want to do this. I don't like fractions. And guess what? You won't be the only one. So come and sit back down. Okay. You're not the only one who doesn't like fractions. But guess what? We can do things we don't like, and we can do them well. All right. It's not about difficulty is not an excuse for failure. Let's be very clear. It just might mean you need a little bit of help, and that's why we're here. So let's take our time, take our breath, and I'm going to say it again. A percent is simply a fraction. Now, what kind of fraction is it? It's a special fraction where the denominator of that fraction is 100. Okay, and that is literally it in terms of what is a percent. Now, people may have a longer definition, and that's okay, but this is just what it is. This is the basic of it. Now let's get a little bit deeper into that. If I tell you that a percent is simply a fraction with a denominator of 100, then that also means that if I am told I got 5% or something, then that simply means, oh, that's just 5 over 100. That's what it is as a fraction. If I'm told I have 20%, and I'm going to have to change this. All right, there you go. So if I'm told I have 20%, then that simply means I got 20 out of 100. Okay, that's it. So what did we just do there? Well, we just converted from a percentage to a fraction. That's it, right? So if someone tells you to convert from a percent to a fraction, something that you've been like crying over, stop crying now, because now you know. You just have to put it over 100. But do we stop there? Will you stop there? Well, the question is, after you do that, let's say I have 20 over 100. The question is this fraction in its simplest form? And what teachers might ask you to do is reduce this fraction, okay? Now, this is like a little tidbit added on. But if I'm going to reduce a fraction, what I need to do is look at the numbers that I'm dealing with and ask myself, is there a number that's common that can go into 20 and into 100 in equal parts where there's no remainder? So, for example, 20, a number is always going to be a factor of itself. So that number that can go into both 20 and 100 is called a factor. So 20 can go into itself. You have one group of 20 in 20. And then 20 can also go into 100, okay, 5 times. So there's 5 groups of 20 in 100. So if I were to reduce this fraction, what I will do is I'll divide the numerator by that common factor, which is 20, and I'll also do the same thing to the denominator. Now, it has to be the same number. I can't divide the numerator by one number and the denominator by another number. It doesn't work like that, okay? So let's go. So 20 divided by itself, or how many groups of 20 are in 20? Well, there's one group. And then same thing for 100. How many groups of 20 are in 100? Well, there's 5 groups of 20 in 100. So if I were to reduce this fraction, I have 1 over 5, all right? Now, take a breath. Let's keep going. I'm going to restate what I said earlier. A percent is simply a fraction where the denominator is 100. So that means that if I want to convert from a percent to a fraction, I simply need to put the percent over 100, or in other words, divide the percent given by 100. And then you can reduce that fraction, okay? And I just did it here. Now, that's if they want you to convert from percent to fraction. All right, so we got that. Now, let's keep going. We did this, all right, and we already reduced 20 over 100. We said that's 1 over 5. What we didn't do is we didn't reduce 5 over 100. So 5 is the common factor between 5 and 100. So 5 can go into itself 1 time, and 5 can go into 100 20 times. All right, so the fraction, or 5 over 100 can be reduced to 1 over 20. And we're going to get into this a little bit later, but 5 over 100 and 1 over 20, we call those equivalent fractions. All right, equivalent fractions. Now, I'm saying it, but we're going to deal with it later. Okay, so let's keep going. Let's take a look at some examples of percent questions from your exam, from a BJC or a BGCSE. If I know that a percent is simply a fraction over 100, or a percent, fraction with a denominator of 100, how do I tackle a question in the BJC or BGCSE that asks me about percents? Well, let's take a look. Here's an example. This example is adapted from 2019 paper 2, question number 9, all right? Now, let's take a look. So it says, Mr. Jones purchased 80 pencils. It's a lot of pencils. He discovered that 15% of them were not working. Okay, 15% of them were not working. All right. The question says, how many pencils were not working? All right. Now let's take a look at the question, and I'm going to underline the things that are of importance. The question is asking how many were not working. All right, that's what we're trying to get to. But let's look at the important details in the question in the description above. So he purchased 80 pencils, right? So obviously the ones that were not working have to be coming from the 80 pencils. Yeah? All right. And then he discovered that 15% were not working. So in other words, I'm going to write out exactly what they're saying. They're saying that 15% of the 80 pencils are not working. Not working. That's what they're saying. All right, that's what they're saying. Now, let's move that information. And let's just take a look at what we see. 15% of 80. Now, in a previous session, we said that when you're looking at words in our questions, there are some words that indicate certain operations. And we'll see that come into play here. But let's deal with the percentage for a second. 15% is a percent. So we can convert that to a fraction or a decimal if we'd like to. But let's say I'm going to put it in a fraction form for now. So 15% we said is simply a fraction where the denominator is 100. So it's going to be 15 over 100. Now once I introduce that 100 into the denominator, I'm going to get rid of the percent sign because literally I just converted it to a fraction. So it's no longer written in percent form. And then of in math represents multiplication. Okay? So literally what they're saying to you when they say, oh, I want you to find this percent of a number, they're literally telling you multiply that percent over 100 by that number. That's what they're saying, but they're not saying it. All right, so now let's go ahead and do the math. I have my calculator with me. So we have 15 divided by 100 times 80. And that's going to be 12. So 12 of those pencils are not working. Now, can I convert this percent to a decimal? Yes, I can. But right now, we're going to keep moving. And if we have time at the end, I'll come back to it. But if not, then you'll just have to check out the channel at a video entitled Converting from Percents to Fractions to Decimals. All right, it's not up yet. I'll make sure I put it up by the end of the week. Okay. All right, let's keep going to the question. How many pencils were working? So if we know that 12 were not working, then the next step would be, okay, if 12 aren't working, well, how many do I have left? Well, I have 80 altogether. So I would say 80 minus 12. All right. And that gives me 68. So I have 68 working pencils. Awesome. Now let's take a look at the next question. He sold the good pencils for 50 cents each. How much did he make? Now, let's think about what they're asking us. They're saying for every good pencil, he made 50 cents. So, in other words, for the first pencil he sold, he got 50 cents, so 50 cents. For the second pencil he sold, he got 50 cents. So if I wanted to figure out how much he made for selling 2 pencils, he made $1, because 50 cents plus 50 cents is $1. For the third pencil he sold, he got another 50 cents. All right, so he has 50 cents total when he sold 1 pencil. He has $1 when he sold 2 pencils. He has $1.50 by selling 3 pencils, and so forth. So what you're realizing is that I'm repeatedly adding the same amount of money every single time. And I'm going to add that 68 times. Now in math, repeated addition, whenever you see yourself repeatedly adding the same thing, then that's an indication that we're dealing with multiplication, all right? So to find our answer, we're simply going to multiply 68, which is how many pencils we're going to actually be able to sell, by the cost that we're selling it for. So that's 0.5, all right, times 0.5, and that's going to be $34. Okay, so we went through the whole question. Now the whole thing didn't necessarily talk about percentages, but you saw how the percentages were brought into the question, right? So let's take a look at another example. I have 2 for you, okay? And then we're going to move on to the other section. So Mary purchased the items below from the store. Okay, complete the table to show each total. And I thought about completing the table for you to save time, but let's do it together. It's okay. All right, so let's keep going. All right, so it says the first item was 3 shirts and the cost was $25.50 each. That's an expensive shirt for some people, but $25.50 each. I hope it's a really nice quality shirt actually. And I'm buying 3 of them. So for the first shirt, I paid $25.50. For the second shirt, I'm paying an additional $25.50. And for the third shirt, I'm paying an additional $25.50. So what's happening? We're repeatedly adding the same thing every time. So if I'm repeatedly adding, that's telling me I need to multiply. Repeated addition is multiplication, all right? So we're going to do $25.50 multiplied by the 3 shirts, and that's going to be $76.50. So $76.50. All right. Now, if you want to, you can pause the video and try it on your own. I believe you can do it. Okay. And then you can continue the video if you want and see if your answers and mine add up. Okay. Now, the second row, it says 1 pair of tennis shoes for $89 per pair. Okay, so he only bought 1 pair, so he's only spending $89. Okay, so that's $89 and no cents. Now, I want to say that if you're not allowed to use a calculator, it's me writing this the way I'm writing this. Notice that I'm putting all the cents, or I'm lining up the decimal points. Writing it in that way makes it easier later for me to do the math, all right? So now the last one, it says 6 pairs of socks, and it's going to be $6.90 for 2 pairs. So for every 2 pairs I buy, I'm only spending $6.90. Well, if I am buying 6 pairs, there's 3 groups of 2 in 6. So I'm going to multiply 6.9 by 3, because for every one of those pairs, those groups anyway, I'm going to spend $6.90. So 6.9 times 3, and that's going to give me $20.70. All right, so this is how I'm filling out the table. Now at the very bottom, it says total. So what I'm going to do is I'm going to add everything in this last column here together to figure out what my total is. All right, so we have $20.70 plus $89 plus 76.5. All right, and that's 186.2. So 186.20, which is just 20 cents. All right, so now let's keep going. Now, the only reason I did the whole question is because at least you'll be able to see how you would tackle questions like this in the exam. Charts are a big thing in these exams as well, so being able to read them and understand what they want you to do is going to be important. So I would encourage you, if you have opportunity to, go ahead and look at a past paper and practice those charts, because a lot of the charts actually take up most of the marks on the exam. So if you can do well on the charting, you get a lot of points up front just by answering one or two of those more involved questions. All right, now it says VAT, value added tax, is calculated at 7.5%. How much money is charged for VAT? Now, whenever we talk about taxes are going to be a percent or going to be based on some total, okay? So 7.5% has to be based on some kind of total somewhere in the question, and it just so happens it's based on the total cost that they're going to be paying for these items. All right, so you're not going to choose some random number out of the sky and then do the percentage for. You're doing the percentage based on the total that you're being charged. So another way to think of it like this: when I go to Foot Locker or any store for that matter, and I buy a bunch of things, what they're going to do is they're going to take everything I bought and they're going to add up all the cost of those items, and then whatever that cost is, they're going to add tax on that total. All right, and so that's the concept here. When you're calculating the tax, it's going to be based on the total of everything that you're going to buy. So let's go ahead and do this. So they want us to figure out 7.5% of 186.20. And once again, just like we did before, our percent is going to be over 100 if I'm going to use it as a fraction. So over 100. Once I do that, I can get rid of the percent sign, and of in math denotes multiplication. Okay, and so 7.5 divided by 100 times 186.2. If you want to convert your fraction to a decimal, you can go ahead and do that as well. All right, so what am I doing? Okay, 7.5 divided by 100 multiplied by 186.2. And we're going to get $13.96. Now, if some of you are thinking, oh my gosh, I'm only spending $13 for this? No, you're not. We're not done. We're not done. Let's go to, that's only the tax. In other words, that's how much they're adding on to the total of the items you're going to buy. So what is the total amount paid to the cashier? Well, it's going to be the tax that we just calculated plus the 186.20. Okay, so you're going to spend $200.17 in total. All right, so don't be like carried away by prices that you see thinking, oh, I'm only spending this much. Wow, amazing. You're always going to spend more for the most part. Okay, you're always going to spend more. All right, so we talked about percentage. I have two examples, but I have a couple of things I want to get through. So I'm going to move past percentages for a minute, and we're going to go and talk about hire purchase. All right, hire purchase. And this is another area where we see percentages come into play. Now, I want to explain it for you a little bit. What is it about? Now, here's a scenario, and then we're going to look at some questions. How hire purchase works is this. If you're someone who has money on you, like you usually have like $20 or $30 on you, and you go to the store and you just want to buy a Snicker bar, for the most part, your Snicker is not going to cost you $20. Now, if it does, I would be calling the police because it just doesn't add up. But for the most part, if you have the money for it, you can pay for it. But most people nowadays like to spend money on things they cannot actually afford, unfortunately. So what happens in that situation? Well, in that situation, let's say we want to buy a car. Let's say we want to buy a car that costs us $10,000, okay? Well, for the most part, most people aren't walking around with $10,000 in their pockets, and unfortunately, most people don't have that in their bank accounts either. So what do? Well, the car company says, oh, no problem, you can have the car. You can have whatever you like. And what they'll say is, okay, what money do you actually have? And so Well, you'll say, okay, well, if I bought it for cash, I would only spend $10,000. But they introduced this thing that might be called leasing or hire purchase. That's another way to look at it. And they'll say, okay, well, whatever you do have, you can put that down right now. You'll pay that. And then they'll subtract whatever you give them up front from the total amount for the car. And then whatever's left, they'll say, okay, you can pay this over a period of time, but we're going to add some tax on that. Okay? We're going to add some tax on that because, you're borrowing, you have the car, and we have to make money on this. It's fair. We're giving you something you can't afford, so you're going to have to pay for that. So now, let's take a look at an example. The cash price of a laptop is $650. It's pretty steep for some people. It is sold on hire purchase with a 10% down payment. So in our example, when you went to go buy that car, they said, okay, how much money's in your pocket? Let's say you said, okay, I have $1,000 in my pocket. Well, that $1,000 that you do actually have and you give them upfront is going to be called your down payment. That's how much money you'd have upfront to actually even sign a deal for that car. And let's be very clear, this is just a random example. I'm not telling you go and yeah. So let's keep going. Followed by 6 equal payments of $120. All right, so that's the situation. So what they did was he has to give money up front, and then whatever's left behind, they're going to chop that thing up into equal payments, plus the tax they put on top of it. All right, so it says calculate the amount of the down payment. All right, so the down payment, they gave us a percentage. It says 10%. Now, if you're wondering, is it 10% of the $120? The answer is no. It's going to be a percentage of the total cost of the item itself. So what we're trying to find is 10% of $650. Okay? Now we can do the same thing that we did before. A percentage is simply a fraction with a denominator of 100. So 10 over 100, and you can convert that to a decimal, and that's fine as well. And then of in math, I'm going to keep saying it so it's like stuck in your brain and you dream about it. Of in math represents multiplication. So 10 over 100 times $650. All right. So when you do your calculation, 10% of, what is it, 650 is going to be $65. Okay. So that's how much money they want you to put down. That's not a lot considering. So that is the answer to the first question. Now they want to know the total amount of the monthly payments. Now we're going to go back to the question and take a look. They say they want a total amount of the monthly payments. So let's take a look at the monthly payments for a second. It says 6 equal payments of $160. So I think when I wrote this question, I must have missed out the monthly, but the word monthly. So we're going to do 6 equal payments. So that means the first payment is $120. The second payment is going to be another $120. The third payment is going to be another $120. So we're repeatedly adding the same thing. So that means we are multiplying. So 6 times 120. All right. And we are going to get 720. 720. All right. Now, the next thing it says, what's the total cost of the television on the hire purchase plan? Now, this is assuming you don't have the money up front. That's the only reason people, well, I was going to say that's the only reason people go on hire purchase is because they don't have the money up front. But, I mean, some people think differently. So let's consider the total cost of the television. On the hire purchase, first we needed to do a 10% down. So that's going to be $65. And then we're going to have 6 monthly payments of $120, which is going to be $720. All right, so 720 plus 65, that's going to be $785. All right, so notice you're paying more on hire purchase than if you just had cash. And that's always the case. I don't think I've ever seen it any different. All right, so what you're noticing is it better to pay in full? It is if you can. It is. And if you can't, my suggestion to you would be, well, let's save until we can, right? Or have a plan and have to pay it off as quickly as possible if it's a necessity. But if it's not, you can just save. Now, let's keep going. Lucille, this is our second example, wants to buy a camera for her photography project. Now, this is an adaptation from the BGCSE paper. So for those of you who are doing BJC this year and maybe you are starting to practice for your BGCSE, I mean, this is a good opportunity, okay? Now, she said, okay, the cash price is $1,200, $1,294. VAT is added at a rate of 7.5%. Now we need to calculate the amount of VAT. Now I want you to try this on your own. You can pause the video here if you want to. Try it on your own based on what we did in the last question. And then let's see how your answers compare. Okay, you can do it. I believe in you. I just need you to believe in yourself. And let's go. All right, so the amount of the VAT, it says it's 7.5% of the cash price, which is $1,294. All right, same process. Percent is a fraction over 100, and you can convert this thing to a decimal, and it's okay. Of in math represents multiplication. Now let's do the math. So 7.5 divided by 100, multiplied by 1294. And we are going to get $97.05. All right. Now we want to know what's the total cost of the camera. So the total cost would be the cash price, right? When you go up to the register, they're going to be like, and the $1,294 is going to pop up, and then they're going to add VAT on top of that. So we have $1,294 plus the $97.05. Okay, and that's going to be the total cost for that camera. So plus $1,294. Yep. And that's going to be $1,391.05. All right, there you go. Now, let's see. Lucille, so same person, but different situation. She decides to purchase the camera on a higher purchase plan. And remember, we said higher purchase plans, you're going to spend more, honey. So just be prepared for your answer to be bigger than the last answer. All right. So she decides to purchase it on a higher purchase plan at a total cost of $1,500.93. Sorry, $1,593. There you go. With monthly payments spread over 6 months. VAT is added at the rate of 7.5. They want you to calculate the amount of each monthly payment. Now, I want you to think about this for a second. They're saying that the total cost is going to be $1,593, and they're going to spread that amount over 6 months. Now, if we're talking about spreading something or distributing something or breaking something up, that type of language is an indication that we're dealing with division, all right? So the amount of each monthly payment is going to be, well, and then of course you have to consider VAT. So let's find the VAT first, and then we're going to do the monthly payments. So the VAT is going to be 7.5% of this payment. So we have 7.5% of $1,593. We said that 7.5 is a fraction. It's a percent, fraction over 100. Of represents the multiplication operation. And so 7.5 divided by 100. Once again, you can convert this to a decimal. And then I have to multiply that by 1,593. So that's an additional $119 added to the original price and 48 cents. So if I add the VAT to the monthly payment or to the total cost, so that's $119, 119.48 added to the 1,593 plus 1,593. I'm going to get 17. Now I'm kind of using these, calling it this, but you can say 1,000. You can actually say the whole word out if you want. But $1,712.48. And this is what we're going to spread over 6 months. So we're going to divide this amount by 6 since we're distributing it across 6 months. So that's going to give us, let's see, $285 a month. $285. And don't forget that 41 cents. For the most part, they want their 41 cents. Okay, so $285.41. Now the amount saved by paying cash. How much did you save by paying cash? Well, let's take a look at if we had paid cash. If we had paid cash, we would have paid $1391.05. So cash is $1391.05. And HP is for higher purchase, not the desktop or the laptop. Higher purchase, we would have spent $1712.48. Okay, so how much would have been saved? Well, if we subtract those numbers from each other, then we'll figure out what the difference is. So I'm going to subtract the smaller number from the larger number. So we have $1391.05. Well, the other way around, $1712.48. So $1712.48. All right, so we would have saved, I'm just going to move them around. All right, there we go. We would have saved $321.43. All right, so you save money when you save up to purchase what you need instead of borrowing the money, right? So let's see. All right, so the next area is discounts and markups. And I'm looking at the time and I'm like, okay, we're gonna end here because we're not gonna have enough time to go through the discounts and markups. But I hope what you're able to see is, let me cancel that. Okay, so I'm hoping what you're able to see, I'm gonna go back to that question so you can look at it again. But percentages, you see them all over the place. You use them a lot. And what we were able to do is create equations or expressions from the information they gave us. And that's why we had to make sure we understood equations and expressions a lot better than perhaps we did initially, all right? So when it comes to discounts and markups, we'll talk about equivalent fractions when we talk on Sunday. We'll talk about solving problems when it comes to percentages, when you have to find the percent or find the whole or find the part. All of that will make sense on Sunday, all right? And so for the most part, we got through percentages and higher purchase. We did not get to discounts and markups, nor did we do wages and commissions. So we'll talk more about that on Sunday. So that's something you have to look forward to. And I don't have any muscle work for you, but I will say this. I want you to take a look at this question. And if you want, you can attempt it on your own. And then when we meet on Sunday, we'll talk about it more and more. But for the most part, I haven't gone over it with you. So you're welcome to go on YouTube, on my channel, or on any other math channel and say, okay, how do I find the discount? And see if you can find the answer. Okay, that's your muscle work between now and the next time we meet. And for the most part, your study tip. Let's end here. What's your study tip number 5? Now, when I say number 5, I'm obviously counting down to our last time together. So where are we? I think this should be number 4. Well, no, yeah, number 5. All right, so create a study area. So what does that mean? Some of us like to study on the highway, and that does not work. Now, you're probably like, who studies on the highway? What I'm talking about is the noise level or the level of distractions that are in your area that you choose to study in. Now, some of us, we can't help it. Like you just have a noisy home or you just have noisy people around you. So what I would do sometimes for myself is, and I would say, okay, during lunchtime, I'm going to go and sit in the library and I'm going to eat my food quickly and go and sit in the library and study, because what I knew at the time when I was in high school was that that wasn't going to be a quiet area because nobody's trying to sit up in the library to study. So I would go and I would use that time to study. Now, my home wasn't noisy, but what I'm saying to you is think about the environments around you and the things that are available. And if you're noticing that at home it's very difficult to study, then maybe it might be good to just study for 10 minutes, 20 minutes during lunch or during a break time at school, so you got that out of the way. Or another option was sometimes I would go to the library and study, and that worked for me. Now, if you're the type of person who has a hard time disciplining yourself, like, I just can't do it on my own, then maybe talk to a teacher and say, hey, during lunchtime, can I sit in your room and study? Or during this time, after school for an hour, can I sit down in here and just study before I go home, before I catch the bus? Like, those are options. So it says a quiet area, as little distractions as possible. And one of the biggest distractions for you is going to be your cell phone. All right. Now, if someone really needs to reach you because it's an emergency, they can call the fire department or the police department, right? If it's like a real emergency. So for the most part, if I'm trying to focus on something like intently and trying to get something done, turning off your phone or putting it in a do not disturb setting is going to be beneficial for you. And what you'll find is the more you can focus, the more you can retain the information, the more you can apply the information, and that will improve your grades over time, okay? So we've come to the end of our time together. I'm so excited for this experience. So what's going to happen after this? Well, after this, I'm going to need some time to upload that worksheet for you. And the worksheet initially would have had all these things on it that I wanted to cover today, but we're just going to talk about percentages, converting between percentages to fractions, and then we didn't talk about converting to decimals, but I can add that in there as well, and also look into hire purchase and let's see. Yeah, so we'll do that. So I'll see you on Sunday. Make sure you go over to our YouTube, like, subscribe, and share. And I also want to say this is the last day that we're going to stream to Facebook. All right. So what I'll do is right before our session, I'll just go live personally and let you know, hey, we're going live on YouTube. And I'll post the link so you can go over to our YouTube channel and watch it there. All right. So I'll see you. Bye.